So, good morning and welcome everybody. And thank you for attending to this fourth already IFAC Industry Connect event. I'm Mansef Shiwa, I'm with Polytechnic Montreal in Canada, and I will be moderating this panel discussion. So first, some organizational aspects for this panel discussion. So each of our panelists will first present his personal view through short statements and calls for action, and then we will start discussing specific points related to today's topic. Also, as you have noticed, all the non-presenter participants will be muted and your video will be disabled. To ask your question, please use the Q&A button, not the chat button, the Q&A, and we'll dedicate the last 10 minutes of this panel discussion to answer to some of your questions. So today roundtable, we will discuss the many challenges faced by industry digitalization. And we will discuss practical issues related to concepts and to implementation of digitalization through some industrial case studies. Our panelists today are renowned experts in different industry sectors, including the manufacturing industries, the robotics, process industry, and water supply and irrigation system sectors. So our first panelist is Georg Weichhart. He's a digital transformation expert at Primetal Technologies in Austria. Then we have Alisa Rupenyan, senior scientist from ETH Zurich in Switzerland. Then we have Ahmed Ragab from Natural Resources Canada. And finally, last but not least, we have Iven Mareels, who is now with the Federation University in Australia. So, as announced, I will ask each panelist now to give a short statement and call for action. And we're going to start with Georg. If you want, you can share your slides and go ahead.
Can you see my slides now? Good. Yes, hello, my name is Georg Weichhart. I'm from Austria. I'm a digital transformation expert at Primetals. I was at the, recently it was at Profactor, a research company, and I'm also was applied at the Johannes Kepler University in Linz. I'm dealing mainly with applied research and in automation and robotics. And I'm also in IFAC, I'm head of the TC 5.3 on integration and interoperability of enterprise systems, where I also had the IFAC group on that topic. Just an important remark, since I only started working at Primetals something like 2 months ago, I'm not speaking for anything for Primetals, but these are my own personal points of view. And my observations are not in no aspect related to Primetals business. So I just wanted to remark there are different kind of levels between digitizations and the digital transformation. So like from the technical aspects over more improved processes or using digital technologies And on the most broad aspect would be the transformation aspect, which is a socio-technical aspect, which involves a lot of people and not only technology. I think if you want to boil it down, one of my main observation is that failures in projects in digitalization and digital transformation aspects are if there are many technical interfaces. One would say that automation, maybe in the first observation, one would say automation is already digitalized, but for me, it's only digitized. So there is automatic control with some algorithms, but the transformation aspect is missing. So it's very repeated business. And the more complex it gets, the more stable the processes have to be. It's better if humans are involved because they can capture the broadness and the dynamics, but much better. So workflow and business processes you can find in heterogeneous and in many companies. Where the digital process is simpler and the humans deal with the complexity. Similar or at different aspects, a different observation is that on edge, on distributed information in environment, it's much more or less digitalized because of the heterogeneity again and the distributed nations. In a central cloud environment, it's much easier for digitalization because often there the data is generated in the cloud, all the processes run in the cloud. So if you want to kind of wrap it together, from my point of view, the more complex, the more dynamic, the more heterogeneous, the more distributed an environment is, the less the digitalization and the digital transformation can be done, or up to now at least, and the more homogeneous and the more stable an environment is, the easier it's getting for digitalization. Again, I'm talking more on digitalization and not digitization. Yes, thank you.
Thank you. Thanks a lot, Georg, for your input. Let's quickly switch to Alisa. You can share your thoughts on the topic.
Okay. I don't know why it doesn't go into full screen. Okay. Yeah. So I don't have a slide presenting myself, but my experience comes from multiple research projects joined with the Swiss industry. And I want to talk about the automation levels first to start with. And this comes from such a classification for autonomous systems. It's the SAE classification for autonomous cars or vehicles. So that's why these headings, hands-on and so on, sound a little bit like related to driving, because they are. And autonomous cars automation is somewhere between level 4 and 5. So we can leave the system and it can take decisions. But manufacturing systems are between level 2 and 3. So everything is still very manual. Everything depends only on decisions of operators. It's controlled by low-level controllers, and there is no intelligence in systems. And in manufacturing, the goals which we want to achieve for autonomous systems are that they should be reconfigurable. They should be able to adapt themselves to produce only one part. That's the future business model, where they can receive orders for just one part from different customers, online maybe. Then they should also sense and understand information which comes from themselves regarding their health state, so they can decide if there is a fault and warn any operators or responsible managers for that. And finally, they should be more efficient and sustainable. So there should be some kind of optimization algorithms. And this could be achieved eventually via digital twins, which are, well, difficult to define, but some kind of simulation or model, which is also augmented with data from the system and regularly updated. And methods for achieving these goals, so how we can embed more data into the operation of such systems in all aspects. This is for me digitalization. So we have data-driven process optimization, for example, where we can intelligently change the process, the parameters governing certain manufacturing process. We have adaptive control, which again depends on data during the process, the manufacturing process. We have then modeling and digital twin creation. And we have machine learning methods for predictive maintenance and smart sensors. And smart sensors, these are sensors which can observe quantities which are not really directly observable. So for example, mechanical properties of parts related to their internal structure, which you cannot observe without very sophisticated sensors. So they rely on predictive modeling again. And if we have to talk about what are challenges achieving all this, I think Georg very well has presented some of those, especially regarding interfaces, regarding cloud computation. And what I can see from my collaborations with industry partners here is that it's very much missing this kind of cloud structure, especially. And also the understanding of different interfaces and standards, it's a barrier in a way why, yeah. And here, very, very briefly, I want to say that in my view, one way to achieve these goals of digitalization is to follow what is put in place for robotic systems. So robotic systems, they're designed already with everything, all this in mind. There are new systems where everything is already embedded. So how they can be intelligent, how they can be autonomous and so on. And we can apply the same kind of thinking to manufacturing systems to extend their autonomy, not just to use them for repetitive, simple processes, but also for more sophisticated processes like producing different parts out of metal and anything else that you can imagine. And so I'm not going to details, but just this is a framework based on the same pillars as for robot systems. So sensing, perception, how you interpret the data, and then hierarchical control. So not just low-level control, but something more sophisticated on top of it, which can give us optimization capabilities. Yeah, and this we can discuss, I think, later. So can go back to this later.
All right, thanks a lot, Alisa. We're going to go now to Ahmed.
Yeah, thank you very much, Monsef. I'd like to share my screen. Do you see my screen right now?
Yeah, but yeah, it's okay. Presentation.
Is it okay right now?
Yes.
Okay, so thank you, Monsef. I'm happy to share our one of the success stories achieved by our team at Calmet Energy when we applied digital twinning approach in the process industry. My name is Ahmed Ragab. I am a research scientist at Calmet Energy of Natural Resources Canada. I'm also an adjunct professor at Polytechnique Montreal, supervising a number of PhD and master students. Let's first, I will give brief introduction about our active digital twinning approach, which means that the digital twin interact with the physical system in real time, adapts, simulate scenarios, and propose actions. So as you can see here, we start by collecting the available data, clean them, integrate them to develop the digital twins of physical assets like equipments, processes, and plants. So these digital twins are used for different purposes in the whole supply chain, such as monitoring, abnormal event management, supervisory control, and even product and equipment design. We apply this approach to 2 case studies in the pulp and paper industry. We built the digital twin for a paper machine as a first use case, and this is a success story of a digitalization in a complex and energy-intensive equipment. The objective here is to minimize a specific steam consumption through real-time optimization and automated inefficiency diagnosis. So we acquire the data from the mill historian, and we clean it and develop the machine learning algorithms that make up the digital twin. And we have developed graphical user interface so the operator can have access to the status of the paper machine. And the interface has 3 main windows here: the fault diagnosis and corrective measures, KPI monitoring and optimization. And this digital twin was successfully tested during 3 months of operation in an advisory mode. And we have evaluated the potential impacts in terms of energy saving and greenhouse gas emissions. So here the second case study is the improvement of the control system of heat recovery network. And this is another successful application of the digitalization in the complex system that include local controllers, several local controllers working competitively. And as you know, each of these controllers is trying to achieve its own objective. And in fact, in this application, the process operators are facing many control challenges to coordinate between these local controllers. And we have successfully developed a supervisory control method based on the reinforcement learning. And here I would like to share with you some of the some hints about the success story, the lesson learned, and the challenges we have faced when developing and implementing these digital tools. So we have successfully developed the tool and implemented the digital twin for the paper machine performance improvement after having several meetings with the mill operating staff, talking with them in the same language, trying to convince them with with the usefulness and the expected success of this tool and the benefits, expected benefits. Also, as one of the success of this implementation is we have a generic and flexible approach that can be applied to solve other operational issues and can be applied to other processes. And of course, we have faced some challenges. Most of them are related to the availability and the quality of data. Some important parameters are missing. The data were contaminated by different sources of noises, and the data and also the sampling frequencies of the variables are different. So we faced some challenges, and also the system complexity. It's another challenge. We have high number of operating modes, non-linearity, and fast dynamics. We have another challenge related to the lack of experience of the operators to deal with the AI and data based and digitalization techniques, particularly in the pulp and paper sector. And some of the lessons learned during the tool development and deployment is that combining the domain knowledge and machine learning is a promising approach to develop efficient and practical decision support tools. And this kind of digital tools need multidisciplinary team to develop, and they need to work in close collaboration to each other. And in our team, we have such capacity because we have process engineers, we have data scientists, we have people working in the mill, we are working in a close collaboration. So this is one of the lessons learned. Also, combining diversified machine learning methods enabled us to achieve high accuracy of the developed digital tools, since, as you know, no single method can work perfectly in all kind of situations. And the hybrid modeling, I mean, combining the machine learning with the first principle is a promising approach to develop such kind of tool. This is one of the lessons learned also. And the involvement of the middle staff in the development phase is very important. And one of the lessons learned is that when we put this tool when we talk with the mill operating staff and convince them to put the tool in advisory mode, they accept that. Otherwise, no one would like to have to take risk. So this is some of the lesson learned, and also we have this tool also needs to be updated as the process is changing. And that's it on my side. This is just to share with you what's in our mind. Thank you.
Thanks a lot, Ahmed. Then you will have the opportunity to come back to these important points. I want to switch now to Iven. I think you're still muted. If you can.
Thank you, Moshe. I will share my screen now.
Thanks.
I think you can see the actual display mode. So in Georg's language, I'm actually talking about digital transformation more than I would talk about digitalization. And you already heard from both Ahmed and Georg that culture transformation, looking at the people aspects, are really important. And I just want to stress that point with two examples. One, which I call a failure, which had to do with a very large transformation of a large utility, a water utility, more than 120 years in operations, large infrastructure. They wanted to go to preventive maintenance and instead of a scheduled maintenance, looking at fully digitizing the infrastructure, added AI functionality, digital twin if you like. And particularly they were looking at cost reduction and productivity gains without loss of reliability to customers. Basically an industry 4.0 play for a utility company. The approach was to replace the entire existence of the databases that they had into a complete new platform, which would be an AI-enabled platform. It would be cloud-based, had elastic deployment, and a very good handle of cybersecurity because it would integrate both the operational data as well as the financial data of selling and buying water, essentially. The project had significant overrun in time and cost for all the parties involved. That was the utility company, the maintenance company, the system integrator, the digital platform provider, and the software vendors. In the end, the functionality gains were not realized in the desired time frame, and several people lost their jobs over that issue. But making a long story short, we had some technical issues, and in particular, the main technical issue was that the data was in really poor shape. It was not consistent, not really ready for modeling. And we wanted to overlook the fact that the actual observations in the past mode of operation, namely regular scheduling maintenance, simply did not provide enough data about the failure events that actually were part of the way that the system would fail. And so the heavy tails were not really sampled properly. And there was also some ontology problems because a 100-year-old company has a lot of same words, different words for the same ID or same topic. The biggest issue though was the culture shock. The maintenance crews are not data scientists, and they couldn't simply value why accurate data were so important. And the transformation really stalled because of people processes rather than of the technical processes. In the end, though, having recognized that it was a cultural problem, with a lot of extra work, people did get there. And in fact, we have now a system there where the company is ready to more accept the digital culture and can start integrating in a way the finance and the engineering function in a much better way forward for business transformation. Another company that I work with is Rubicon. And there we do a rather simple system in a way. We distribute water, gravity fed from dams to farms, and we replace an entire digital manual process of ditch workers and manual allocation of water requests through a digital approach. And that means totally automating the infrastructure, totally digitizing the buying and selling of water, even making a market of water essentially. But the way we do that is by first educating people about what is lacking and what is missing, and demonstrating it with trials and test work, what actually can be done if a whole community comes together. And the whole community goes from a farmer to the regulator. And that can be really complex if you have many levels of government working on water. And in Australia, we have 6 levels of government working on water. So getting them all seeing the same thing is not that easy. It's probably the biggest issue. And the success here is to talk about water productivity and finding the win for everybody involved. The regulator is happy because they have a better viewpoint, and the farmer is happy because they can do more with less water. And I would say without that focus on how people actually interact with the system and how they get actually a service, you would not be able to get anywhere. The other thing that's interesting to learn is here, although we almost use the same technology in every country where we implement this, the culture transformation is totally different in every jurisdiction we have worked, whether it's in the United States or Chile or India or China or Australia. They're all different. They're actually location dependent. And so my message is, if you want to do digitization or digital transformation, then you're looking at both a technology transformation and a culture transformation. Thank you.
Thank you, Iven. Thank you, everybody. I think there were several very critical points that were raised during your presentation. And I want to go directly to the heart of the discussion, of today's discussion. And if I ask you, in your experience, what is currently stopping companies from full adoption of digitalization, what would be your answer or your opinion on that? Why not all the industry, the technology is ready, why not industry are today fully digitalized? Who wants to start?
I'll give a quick opinion.
Yes.
Companies know the hype, but they don't understand the process. And Ahmed made a very good point. Data comes in all forms and shapes, and very rarely data have been gotten the attention that it deserves. So in any process that I've gone through, getting the data right is about 80% of the work. And when you tell people that, they say, "Ooh, are you sure?" And say, "Yeah," and then they get scared.
If I may add something here, so what I've seen is 2 things. Maybe I mentioned them already, but really, without having good integration in the cloud, where you have high computational capabilities, I think that will not bring very scalable results. So some small aspects can be digitalized, but especially for larger companies, they need to have some kind of very seamless integration with cloud or edge or both. And the other thing is interfaces. So especially for predictive maintenance and so on, if there is a manufacturer delivering some components or systems to a customer, they still need to retain access then to data from these systems. And this is still not very well established how to do it. I think there are some emerging technologies, OPC-UA and so on, and some protocols and standards, but they are not yet well known.
My observation, I agree on. So it might be on a different scale, but the interfaces in general, also to other software. I mean, isolated. I see isolated, smaller pieces automated, but the larger, the flexibility is missing due to non-modular structures and missing interoperability, and missing lack of proper design interfaces. So there is smaller work, going on, but not the large things that we are talking about.
Some companies are really trying, though. It's not like, I mean, I worked 5 years for IBM, so in that space, we do some really big digitalizations and digital transformation. That's actually the whole company in a way. The IBM consulting company doesn't do anything but digital transformation. Most of it is based on the business processes, so it's not as technical, but there are quite a few where actually the technical transformations and that we integrate from the shop floor down to the CFO's office, all in digital. And you're absolutely right, Georg, that is getting the interfaces right and planning that and making that all work is a really, really big thing. But putting it on the cloud, yeah.
In particular, if you have existing software solutions and other, I mean, it's not a homogeneous field. It's you got too many software APIs lying around and
SAPs and there are lots and lots of vendors.
If I may add something, if I take the process industry, sector as an example, it depends on the industry itself. I mean, for example, it depends on the sector. For example, in the oil and gas industry, it's more advanced when we are talking about the application of digital tools. But when we are talking about the pulp and paper industry, people in pulp and paper mills to a large extent still hesitant to adapt these models. And I mean, this industry is still skeptical on the use of AI or digital methods, since, I mean, there are database solution, and as Iven talked about the problem of the data, rather than traditional physics-based and knowledge-based approach. That's why they're still hesitant. And I mentioned it in one of our challenge. We were working very close with them to convince them to adapt these techniques. So it depends, in my opinion, it depends on the sector itself. And some sectors it's a bit advanced. Other sectors the maturity is not, the level of maturity has not been achieved yet.
Okay, interesting topic. I want to stay a couple of minutes more on this aspect, because I think a lot of participants are interested in that. Could you comment on the visibility of value brought by digitalization? Is it clear for everybody? Ahmed just mentioned that, for example, pulp and paper sector does not seem convinced by the fact that digitalization will provide significant return on investment. In your experience, people are convinced, and then it's a matter of technical challenges or other things that blocks the adoption of digitalization, or you have to explain and provide arguments before even the project starts?
I think you always have to provide a business case in order to get the project to start, right? So it is a bit difficult because it's not obvious how to estimate in advance of an automation project how much you can actually optimize, because in the end, a manual process could be close to optimality, and then you don't have a lot of margin to play with, right? But typically, digitization does give you really one big advantage. It's an accountability that is lacking in general. And that's a very big selling point. And so normally getting your foot in the door with saying, we now can account for what you do and what you don't do is a big step forward. The visibility that Alisa was talking about with smart sensors, things that you could never otherwise measure, now you can suddenly get an insight into it. Flows of your water, your energy consumption. Just keeping track of these things. Looking at United Nations Sustainability Development Goals, everybody wants to account for carbon. You can't account for carbon unless you start measuring things. So that's a good step. And once you see the benefit of that, then you can ask the question, well, what can I automate? What can I make better? How can I manage these things so that I get better results? And that's where you then start identifying what the real benefits are. And typically, almost in every industry, we can do better by having a holistic systems engineering point of view, rather than by just focusing on this particular little loop or that particular little loop. Because in the end, I think that's what classical control has done. It has helped it enormously, but it hasn't created the value from end to end. And that's where things like model predictive control have made a huge name for themselves, because they try to do that. Economic optimization, but it's this end-to-end point of view, systems point of view, that you can achieve. And Alisa talked about digital twin. I think Georg talks about it as well. That's the modern language for model-based systems engineering end-to-end.
And also, since you mentioned most of the return of investment, it's very important to convince people that this digitalization tool can bring value, and as you know, for some industries, the return of investment is in short term. I mean, it's 1 year or 2 years, and that's why it's one of the.
You're lucky. 6 weeks.
Yeah, in some cases, they don't want to interrupt the production. They need something that in the short term. That's why it's very important to take this into consideration also.
Yeah.
Thank you, Ahmed. Thank you, Iven. Just one quick question about how to implement digitalization. You mentioned even in your first example that you have to implement a completely new IT infrastructure, if I understood well. Is that something that people would accept, or is it wiser to build on the existing? Maybe Georg or Iven can comment.
Okay. One turn back. I mentioned that's what the decision was that was made. I'm not saying that that was the right decision. I think part of the problem was that they were trying to chew off too much in one go. And that's an issue. Normally, the approach we normally take is a co-design approach, a bit like what Ahmed mentioned, that the people on the plant are actually really important. That's the way that I would normally try to do. And I would start with pilot and then grow from small to big, rather than doing everything monolithic, holistically approach. Exactly. This was one of the mistakes that the utility company had made, in my opinion. And once you start with that, they couldn't undo that anymore. So we were basically stuck trying to make it work. And we got there, but it took us probably 3 times as long as we ought to.
And also putting the tool in advisory mode, I think it will convince them. We are not going to. I mean, the best way is to put this tool in advisory mode first. Then, once they found they realized or they achieve some tangible impact, they can.
Yeah, this was nothing more than advisory. Yeah, there was no control loop involved to those. It was just preventive maintenance and better scheduling of maintenance. So this was purely advisory, both to the maintenance company as well as to the utility company. But still, if you have, I don't know how many millions of items to play with and digitize and put in a new database and make consistent and get the maintenance records consistently, I don't think anybody really understood how bad the data were when we started. It's a hard work. So, but that's one example of a complex place with lots of difficult interfaces, lots of people interfaces, different people interacting with data in different ways.
Yeah.
Maybe for such cases when there is some doubt, it's better to talk about decision support to start with, and then fully digitization and so on.
advisory or passive and then contributor.
By the way, there's a question in from the audience in the Q&A section. About the low-level data interfaces. Yes, this kind of reflects a little bit my experience that data scientists that are obviously focusing on the data want it in the cloud and then work with their tools that are in the work. The engineering is missing often, and sometimes because it's simplified research setups where the data is coming nicely. And then when you go to the real world where the data is not coming that nicely, or where you really have to think how to model, how to integrate different other systems, how to make it more interoperable, then you are challenged. And there might be not a common, or there might be ontology. There are ontologies partially doing a job on the semantics. There are some interface standards for writing these, like MQTT in manufacturing is hyped currently and very much used. But still, there is no way, there is no method for the data engineering and the models, and also no method how to deal with low quality data. I'm missing that. And in addition to that, Iven mentioned it, I think. In manufacturing, luckily, we are missing the bad examples often. I mean, even during ramp up, you do not want to have like 50% of scrap just to get your data right. So there needs to be some new ways to think on the data and how to get it and what to do there.
Yeah, I think also Daniel points out in his question that sample rates and dynamic models are not necessarily part of a data scientist mode of thinking. And that's quite right. And that's, I think, a reason that I think controlled people have to talk to data scientists to explain what it means to have maybe a non-minimum phase response, or to have what is a time constant. Even that concept is often foreign to these people. So how you sample is not easy. But I have found that when you work with those people, that they do get it, and models with dynamics and time dynamics and so on, even variable time dynamics or event-driven dynamics, they get around it quite well, but they certainly don't have the tools readily available to deal with it. So that's where you start having control engineers working together with data scientists.
It's very important. It's very important. And as I mentioned, in our team, we have, we are lucky because we have this, we consider ourselves like multidisciplinary team. We have process engineers, we have data scientists, and we are working at the same time with the mill operating staff. We have different view. That's why we come up with successful application, successful case at the end. But this is one of the lesson learned. It's very important because sometimes we don't, as a data scientist, as you mentioned, even we don't have any information about even the shutdown periods. We don't have information about many things in that. So the process engineer explained this to us with the mill staff. So it was very important really to have such kind of collaboration to have successful tool at the end.
Yeah, in consulting engineering, people normally work with design teams of SMEs, subject matter expert of different domains that cover all of that together. That's the best way forward I've seen working. And I find that those teams actually work very well typically. So I totally agree with your approach. I like that approach. It's good.
And maybe another way is when in the beginning of such interdisciplinary collaboration, to sit together and define the architecture very carefully. This is what I learned the hard way, that we should define it in advance with all these aspects taken into account.
Yeah.
And not wait that your control engineers turn into data scientists.
Yeah. And it's important for all this multidisciplinary team to have like common language between them. I mean, this is very important, because sometimes when we are talking about support vector machines, neural net, people in the middle, they don't understand that. That's why it's important to unify the terms used in our discussion when we are developing the tools.
Yep.
So we talked a lot about data, about platform infrastructure, IT infrastructure. I want to hear your opinion on methods. A lot of people are interested in the type of methods that you are using, specifically the grad students, I would say. Like you just mentioned, there are plethora number of methods in machine learning, in data analysis. How do you pick one? Do you pick one? How do you pick one? And what is the logic, or it doesn't matter at all?
That's a good question. I can add. So, oh yeah, go ahead.
No, go ahead, Ahmed. Go ahead.
So our approach, I'm just sharing with you what our thinking. I mean, we rely on diversified methods, since no single method can work perfectly in all kind of situations, all kind of application. That's why we are relying on supervised methods, unsupervised methods, and even reinforcement learning methods. So because each of the methods, and I will give some examples, has its own algorithmic infrastructure, so it can deal with the data in a certain way. Our approach, for example, if I talk about the classification as one of the important problems in that can apply to many applications, the classification, we are using ensemble of methods, and finally we integrate the decision of each method to have a unified and accurate decision. So the ensemble in the case of classification, it's, in my opinion, we tested it and it was very, very accurate compared to using single method. Regarding the which method, so we should test different methods given the data, and we should select the most accurate one, put all of them together as in an ensemble, and diffuse their decision to have more accurate decision at the end. This is just one of this is what we are doing. And also the unsupervised methods, we are doing the same exactly. The same concept. Since if you know, key nearest neighbor, we have many unsupervised technique, clustering techniques, and we have to test and select the best one, the best ones, and in fact we are not going to rely on just one method.
Yeah, I would agree also at a large level that that's the case, Ahmed. The problem is a problem. It's never a methodology that you have to apply, and there is no problem in business that's purely engineering or is purely business or is purely science, data science problem. They're always mixed, and you have to bring the right tools to the right environment. The architecture that Alisa mentioned is really important, and there is no unique answer for an architecture. But once you've chosen a data architecture, once you've chosen a data modeling or approach to keep data and keep models, and models are data, by the way, in my language, you have a way of doing it and tackling it, and then you have to be consistent within that. Big companies like Siemens, ABB, they have their own frameworks in which they do that, and they can be quite dogmatic about it because they think in that framework, they teach that framework. So Michael had a very nice question. Do people actually recognize the importance of upskilling people in-house? And do they recognize the importance of having a technical leader? So definitely in the say software industry and IT industry, it's well known that architects play a very important role, and they're kind of the technical leaders for their companies. But you'll find that now you find a technical leader in a bank is a very common thing. The finance industry has technical leaders, and you will find that the technical leaders are actually part of the C-suite of companies because it's so important. And it penetrates every part of the business essentially. And so the more we digitize, the more we integrate, the more you will see this happening, and the more people recognize that everybody has to be upskilled. It's not a matter of having a few people that know what's happening. It affects everybody's life. And just like we all have to be cybersecurity, not experts, but we have to be aware that we are the weakest link in the network, right? And so what are our behaviors and how do people actually behave? We have to respect data. It wasn't a long time ago that the data people were actually the cheapest people in the company. Nobody really cared. They made some notes, right, in a paper, and we didn't really use them that much. But now data are the gold, the new gold that people are starting to mine. And suddenly the value is totally different, and people that look after data become very important. So I do think it's rising. It's by no means the revolution that people expected it to be. But yeah, bigger companies where things are really important have digital leaders and technical leaders, and they call them like that.
And in less than 1 minute, Monsef, if you permit me to add something, also related. I mean, we are not only focusing on testing the algorithms itself, because it's one side, but also the data. It's related to the previous point that we discussed, but can we fix the algorithm and improve the quality of data through transforming it into other representation? And this is what's called data-centric AI. I mean, because the algorithm reached a certain maturity level, it's okay. All the algorithms are there. They have a lot of open source library that are very mature. But how about playing with the data itself? I mean, should I transform the data into useful representation that can be used to train the algorithm itself? So this is also one aspect that many people right now, they are talking about learning representation. It's not learning from data, learning from the representation that we got from the data. So this is also one part. It's called data-centric AI.
Thank you, Ahmed. Thank you, Iven, for your interesting comments. We already took 2 questions then from the audience, from Greg. We have another one from Russell, and Russell is scared that overselling digitalization could have a negative impact. Do you have any comment on how to sell digitalization, on how to oversell digitalization?
Russell is absolutely, yeah, so go for it, Alisa.
I have one comment here. I think it's very important to convince then the customer or of the value by really connecting it to something tangible, like, for example, standardization. So what I see on smaller scale companies is that this is very much missing, standardization. And actually it is a baseline that needs to be achieved for digitalization. And they very well can see that, for example. And this is a way, and the other thing is to put a mechanism on how to maintain the models or the processes that are introduced. So of course, either there should be a mechanism for self-updating or a regular updating of this and recalibration of these models. This is what I want to add.
Yeah.
Okay, so you discuss sustainable solution digitalization, but I want to hear you more about the overselling.
Yeah, so yeah, go, Georg. No, you go, Georg.
I see this overselling challenge in science and in industry. I mean, we have the hype cycle that we are all aware of in both worlds. Does it good? I don't know. In the short term, it does good because it attracts money. In the long term, then you have a huge gap where stuff gets cleaned out. But it's not specific to industry or to academics, it's everywhere.
Yeah, I absolutely agree, Georg. But it does cause damage, and it does cause a dip, and it can cause negative experience with especially when on the receiving side, on the client side, there is not enough knowledge to recognize that someone is hyping. And we sometimes get carried away by our own ideas and they're the best since sliced bread and so on. And if the other side then overinterprets as well, because they have this problem and suddenly they can solve all their problems, they oversell internally in the company, and then you really get a cascade and egg on your face everywhere. And sorry, Russ, you're right. That can get a very negative experience, and it may well lead to companies not progressing with digitization at all, or even shunning it. And I can give you examples, but then I would be in trouble.
But when we talk about, in my opinion, in my opinion, AI or the digital tools should be developed and operate under the full supervision of the human.
Even then, Ahmed, even then, IBM doesn't do anything but that's our first mantra. AI is to help a human.
Exactly.
But that's not enough. That's not enough. Even if it's only helping a human, you have to train the human how to work with a tool that is not as clever as they are. There's a whole human-machine interaction that we're totally underestimating. And I think this is one of the problems that why we don't have level 5 autonomy in cars. Cars can, if it only were cars driving, it would be easy, but they have to drive with humans as well. And that's not easy. Because humans are not rational.
We should prioritize the decisions. I mean, give the expert or the human the right to take the decision with high priority, not giving it to the AI. AI can do repetitive tasks. That, I mean, the idea is to minimize the effort by the expert or by the human, not to replace the human. This is my
No, I totally agree. But even though you do that, it's still not enough, because the human may not be able to control the AI. Like in a car, if a car is autonomous and you are driving a car, you're not controlling the other car. You're only driving your car. So the car has to work with you. It's the human AI interaction that we have to understand. And for the moment, that's still elusive.
Yeah, that's important. I understand this.
Yeah. So Hakim has also a very interesting question. I don't know who wants to take it, but should companies build their own internal capacity, or should they go for external specialists and ask for advice and go for the largest software engineering companies, for example?
My opinion on that is that they should build some internal, they need to build some internal capacity for their particular purpose. I mean, at the end of the day, you have to translate the tools and the AIs and the data in both directions somehow. Either you explain it to the humans, or the data from the humans, or from the tools from the sensors go to the software. So these flows needs to be translated here and there. And you typically have to repurpose the tools to the specific nature and the context of the company. I mean, the companies have their own very specific context, their own. This is why they are good. This is why they distinguish to the other companies. I mean, if all the companies would work the same, then there wouldn't be any. But so they're doing business in a specific way, which make them hopefully better compared to the other companies. And you have to repurpose the tools to this context. You might start with a larger consultancy, but at the end of the day, you need to have this translation in-house. I
totally agree, Georg. People need, if you want to buy a car, it's good that you know how to drive a car at least. So you need to be a discerning buyer, I would say. On the other side, if you want to do something quick and get results quickly on the board and accelerate without necessarily giving up your own identity, then working with a consultant company is actually meaningful and can make it work faster. So, but yeah, internal capability always helps.
Excellent example, by the way, that if I want to go to, you have no car, no algorithms, no AI, and you want to go somewhere, you take a taxi and consultancy. But if you want to do it regularly, yes, go ahead and learn how to drive.
Very good observation. So I think that's the perfect time, unfortunately, to stop our webinar. We already are over time. I would like to thank again all our panelists today for the valuable comments, and I would like to thank the audience for their attendance and also for the very interesting questions that we have received from you. Just a reminder, we plan to do this kind of event every couple of months, so please have a look at your email. You will receive probably soon the invitation for the next webinar. We are always organizing and planning the next webinars of IFAC Industry Connect. So I'm talking to the audience. If you feel you have the will to participate to this event, please contact me and we can discuss an interesting topic for future webinars. So thanks again, everybody. Thanks to the panelists, and I see you the next IFAC Industry Connect meeting. Thank you.
Thank you for having us.
Thank you.
Thank you.
Have a good day.
Thank you.
Good to see you.
Okay.